Welcome, calculus people, to lecture 2.6c. We're going to stay with this is our last lecture for related rates. And I'm only going to work one example problem because I haven't worked an example problem yet with a changing angle. So one of your homework problems has an angle. You want to know the rate at which an angle changes. So I wanted to give you an example problem for that. So on your sheet, your note sheet, we're going to do example 42 on page 148. So you've got some space there to write that in. All right, so let's go. All right, reading through this problem, and they give us a nice diagram. It says a fish is reeled in at a rate of 1 foot per second from a point 15 feet above the water. At what rate is the angle between the line and the water changing when there are 25 feet of line out? So as the fisherman reels it in, then you know that the lure down here, oops, made a mess, is going to be moving this way. So the angle theta is going to be getting bigger, right, as that line keeps moving this way until it's about straight up, and then he can pull it up out of the water. Okay, so let's draw this out. Okay, so I've got this situation. We're calling that length of the line x, and we know he is reeling it in at a rate of 1 foot per second. Let's see, yeah, 1 foot per second. We have this angle theta. We know it's going to be getting bigger as he reels it in, and we also know that this is 15 feet. So between the dock and the water is 15 feet. So we want d theta dt. We know that dx dt, now we have to put our thinking cap on a little bit here. This line is getting shorter. So dx dt is actually going to be negative 1 foot per second. Now let's say that you forgot to pick negative 1 and you just put 1. When you work the problem out, then you're going to see it would show the angle is getting smaller rather than bigger if you pick 1 instead of negative 1. And then you could go back and just fix it really quickly. Okay, so you have to think through the situation. Is theta getting bigger or smaller? And then make the sign give you that. But since the fishing line is reducing in length as he reels it in, that common sense says that, okay, it needs to be negative. And we're relating. So what you need to do is pick the trig function that uses the fixed side, so the known fixed side, which is 15 feet, so that would be the opposite side, and the side which you know the rate, which is the hypotenuse. So what trig function is opposite over hypotenuse? It's sine. So we have sine theta is equal to opposite 15 over hypotenuse x. So let's write that down. Choose the trig function that includes the fixed side, so that'd be the 15-foot side, and the side where the rate is known. So we know the rate of the hypotenuse at 1 foot per second rate for x, and we have a fixed side here. This side, this opposite side, the adjacent side to theta, is also changing, but we don't really know anything about it. Okay, so we can't choose that. So I'm going to rewrite this as sine theta is equal to 15x to the minus 1. That makes the derivative easier to take. We're going to take that with respect to time. So that would be cosine theta d theta dt. Don't forget d theta dt. If you do, you're not going to be able to solve for it, so you'll probably figure it out. Is equal to negative 1, bring it out front, minus 15x to the minus 2 dx dt. All right, so I'm going to, solving for d theta dt, it's going to be negative 15 on top. Dx dt stays on top. The x squared, I'm going to divide them, bring that cosine theta underneath. And the x squared, I'm going to have that come downstairs so it makes it positive. And now I can plug in what I know. Now, I know that x is equal to 25 feet at the time that we're interested in. If you use the Pythagorean theorem, you'll see that at this particular instant in time, when x is 25, then the adjacent side would be 20. So just use from the Pythagorean theorem to get that. All right, so we would have minus 15 dx dt would be negative 1. Now cosine, so we do have to remember, is adjacent over hypotenuse. Right? So the adjacent side is 20 and the hypotenuse is 25. So that's cosine right there. And then x squared would be, we know x is 25, so times 25 squared. So negative 15 times negative 1, that's 15. If you put all this in your calculator, 25 squared times 20 over 25, it is 500. Probably in this case, it's easier to make that into a decimal, so that is 0.03. And the unit would be radians per second. Okay, so your homework starts on page 146, and it's 28, 30, 31, and 43A. So let's just look at these real quick. 28 refers to this figure right here. It is not an angle problem. So you'll just draw out this triangle. You won't be using any trig for this. And you're just trying to figure out, determine the speed of the boat. All right, so the boat is coming in straight towards the dock. And you're going to need to get, as you assign your variables, whatever a variable you assign to that horizontal distance, you'll solve for that rate. So nothing really new there. Number 30 refers to this figure right here. You've got the plane going out that way. They give you S, both the distance and the rate. So you're trying to get the speed of the plane. Of course, the plane is flying straight, so you're looking at the X side of the triangle there. That's no different. So this one is a Pythagorean theorem problem. This one's a Pythagorean theorem problem. Number 31 is a baseball problem. So you need to go back and look at the example and draw this out. The only difference here is the player's running from second to third instead of home to first from our example. So you'll be drawing that triangle and determining the rate at which the distance between home plate and the batters is changing, but it's very similar to the example. All right, now the one with the angle is number 43. So you're doing 43A, which is just the 30 degree when you don't have to do B and C. So in this one, we have the plane is flying to the left here, and theta will be increasing. Theta will be getting bigger. You have a fixed side, right? And you also know the speed of the plane. So that's this speed going from right to left, right? You know that speed. So you'll pick the trig function that goes with the fixed side, which is 5 miles, and then the speed of the plane side as you draw this triangle out. And whatever, I'll let you figure that out, but that's the what you'll be picking, the trig function. You need to use that. Now 30 degrees, you use 30 degrees to figure out the unknown side. At when that angle is 30 degrees, you need to use trig and use SOHCAHTOA and figure out, what the different distance is, whatever distance you need to solve the problem. But your final answer will be in radians, that 30 degrees. So you might have to change your calculator to degrees for just a second and then change it back to radians. But your final answer will be in radians for that. So I'll make a solutions video for those 4 problems, and then you'll pretty much be ready for the test. All right, so good luck, and I'll talk to you on the solutions video.